In question 3 of this exercise, the problem statement says a 15 meters long ladder reached a window 12 meters high from the ground on placing it against a wall at a distance A. We have to find the distance of the foot of the ladder from the wall. So I want you to observe this figure carefully and let me talk about the various aspects of this figure. So we have this ladder that you see that is 15 meters long, and this ladder is placed against a wall. So this is the wall, such that it reaches a window. The window would be somewhere here, and this window is 12 meters above the ground, and the foot of the ladder is at a distance of A meters from the wall. Okay, so we have to find this distance A. Now if we observe the figure carefully, we can see that a kind of a right triangle is being formed in this figure. And what are the sides of those right triangle? So we have the ladder itself forming the hypotenuse of the right triangle. We have this part of the wall from the window to the ground, which is 12 meters in length. This is forming the vertical edge of the right triangle. And then we have the ground itself, which is forming the horizontal side of the right triangle. Okay, and this angle here is 90 degrees. So all we need to do is to apply the Pythagoras theorem to this right triangle, and that will give us the value of this unknown side, whose length is A. So let's apply the Pythagoras theorem. So we must have the square of the hypotenuse, or 15 square. This must be equal to the sum of the squares of the other two sides. So this must be equal to 12 square plus A square. Okay, so this gives us A square equal to 15 square minus 12 square. Now 15 square is 225 and 12 square is 144. So we get 225 minus 144, which is equal to 81. So A square is equal to 81, and this means that A is equal to root of 81, which is equal to 9. So the value of A, the length A is 9 meters, and this means that the foot of the ladder, this point, foot of the ladder, is at a distance of 9 meters from the wall. So the answer for this question is 9 meters, and this completes question number 3.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.